syllabus because we've got a few things to fix on it in our schedule. Last time I talked about doing the motor project and not the trebuchet project, but I forgot that I actually included the motor project in Chapter 5 exam because I changed my Chapter 5 exam this year to include a project. So we're not actually going to do a motor project. That's actually already done. We have a couple of different projects that we can put in its place. First of all, we could, let's see, what is today? Today is the 12th, right? So, yep, so we're actually right on schedule because we skipped the exam. That's nice. But we now have some extra time in here to put in some other things. We've got the hydraulic arm project is actually, it could actually be split into two projects. A simple hydraulic arm and a more advanced hydraulic arm. And that's what I've done in the past, but this year I decided to kind of cut it down to one project where you just do the more advanced one. So that is, I think what I might do with this hydraulic arm project, let's see, for the SketchUp computer-aided design, we've got 1, 2, 3, 4, 5, 6, we've got 2 full weeks essentially to work on that before Thanksgiving. And then we have 2 full weeks to work on the 3D printing of our project, our final project. And so and this one originally, this final project with the 3D printing and the SketchUp, I was going to leave it a little bit open for you guys to do what you want, but I decided not to do that at this point. I think what I'm going to do is have you guys, I'm going to have you design a quadcopter drone kind of thing. I don't know why they call them drones. They're just remote control helicopters. But I'm going to, I think they have these kits out there that are kind of cool where they give you all the parts to make one of these drone things. They give you 4 motors and propellers and the little computer controller and the camera to put on it, and they give you the radio transceiver, and then you have to design, you provide the body for the helicopter. So you design the body of it, and then you put it all together, you do all the wiring, soldering, whatever else, and then you can use your cell phone, I believe, to control it. And these kits are not terribly expensive, and so I think I can purchase enough of them for this class. I might even do this in my other engineering class here at the college. But I like the idea of doing something that is a little more, just a little more of what's going on today, kind of a little more today's news, right? And right now, drones are definitely today's news since I heard it on the news this morning. They're talking about how drones are going to change the economy of America. Well, I don't necessarily think that's entirely accurate, but they will definitely be doing some things in America. And engineers will have an opportunity to participate in that. Engineers, technicians, and gamers, in fact, because gamers are going to be the people driving these things. But believe it or not, there are not very many drones that are autonomous. There are very few, and most of them belong to the military. But in fact, most of the drones in the military aren't even autonomous. Most of those are actually driven by somebody at one end. But the point is that I think that that's what that project will be all about. In the 2 weeks before Thanksgiving, we will spend about 1 week learning SketchUp, doing some tutorials, and then we will spend another week starting the actual design of your quadcopter. And then, by the time we get back from Thanksgiving, hopefully that is completely done, and we can start the 3D printing process, which is not as quick as people want you to think it is. First of all, you have to turn your three-dimensional design in SketchUp into a tool path that can be used by the printer. And then you have to make all kinds of decisions about how you're going to print it. Do you want to print it as a hollow piece or as a solid piece, or what kind of material do you want to print it out of, and everything else? And then the process of actually printing it has usually many iterations. First of all, you're going to print it, and almost guaranteed you're going to have a bad print the first time. And then you're going to have to adjust the design or adjust the printer somehow, change the material maybe, so that it will print the way you want it to. There's almost always a mistake, or the printer makes a mistake because the 3D printers are just that way. Particularly the lower end ones, which is what I've got. I've got a 3D printer which is considered the high end of the cheap do-it-yourself models. It's a maker-bot replicator, and it is probably the most reliable of all the 3D printers that were made in garage, in somebody's garage. My printer was made in a guy's garage in the Bronx, New York, or Brooklyn, I can't remember which, but probably the Bronx, because Brooklyn's a little more expensive than the Bronx. But it was made in this guy's garage. Eventually his company was purchased by a bigger company, and now they're made in factories. But it's still pretty good, pretty reliable, and worth having. So hopefully in the future we'll get an industrial quality three-dimensional printer that's, the $100,000 variety. But we'll see about that in the future. So, there's a lot of things involved in actually getting a 3D print to be functional. And it may take all 2 weeks that we have set aside for it to get an actual 3D print out in time for you to test it and make any changes that you might want to. Also, we have this time delay between you making the project, sending me the project, me printing the project, and then telling you what went wrong with it, because we will spend class time looking at printed designs and telling students what went wrong, what they need to fix, if they need to fix something in their actual design, or if we need to fix something with the 3D printer. Also, I will make myself available to you if you are interested in coming to the college to see the 3D print. Which brings up another question. Do you have a 3D printer available to you in your high school or anywhere nearby? What type of 3D printer is it? Replicator? Is it the one that's made of wood, or is it the one that's made of metal? Okay, so you have the later version of that. I don't know much about the later version. I've actually heard that the later version is not as good as the wood version. I don't know if that's true, but that's just what I've heard. So, but I assume that there is somebody in the library that knows all about that and can help you with that there. Okay, so maybe what I'll do, where are you at again? In U10? Where is U10? Okay, so maybe what I'll try to do, I might be able to work it so that I can drive out there when it's time to print and spend a day there setting up your printer. As far as I understand, it's still built the same. I mean, all the internal moving parts are still the same as the original one. They just added on some extra features, and they upgraded the computer on it. That's what I understand. I could be wrong. But I will come out there and see if I can. I will try to. I'm not sure if I'll be able to, but I'll try to make some time, spend a day, drive out there to U10. How do you pronounce it? U10 or U10? U10, okay. Somebody else says it's U10, but that didn't sound right to me. Anyway, okay, so I will try to spend some time. I'll try to get out there. to visit your school, meet with you, see if we can print on your 3D printer there. Unless somebody else figures it out before I can get out there. If somebody else figures out how to use it and they become an expert in it, that's fine. But I know enough about the replicator that I should be able to do that and get that working in a day. And then you could actually see the 3D printer in action printing your design. And that might be a really fun thing for your school and maybe a news story for your local newspaper or something. But anyway. Well, that's fine too. I'll be happy so I'll actually try to contact the public library out there as well and see if they have somebody that knows how to use it so far. I'll try to make some contacts because that would be ideal so that you can actually see it working and be there for it. It's not really practical for you to come to North Platte, so the best that I could do probably is make a video of the printing process, which is a real pain in the neck because it takes like hours. You know, printing a helicopter would probably take a good 4 or 5 hours to print. And then something goes wrong, you have to start over. And so it's much better if you can be there while it's happening so that you can start it over or you can figure it out. When we come closer to that time, right around Thanksgiving, the week of Thanksgiving probably, we'll talk more about this, and I will and we'll set up a good day for you. I don't know if you'll be around over the Thanksgiving break, but I will be, and it would be an ideal time for me to come out there. So yeah, so anyway, do you normally stay home for Thanksgiving, or do you go visit family, or what? Okay. Well, what I might do is do you have classes? Do you have school the Monday and Tuesday of the week of Thanksgiving? What I might do is I might just come out that Monday, the Monday before Thanksgiving, and spend the day out there working on that. And if I do, and maybe I might come Monday or Tuesday, depending. But we'll work at that out the week of Thanksgiving, the week before, and decide what we're going to do and see if we can get a 3D printer up and running for you. And what that would mean is that I would spend, a couple hours out at the library figuring it out, making it work, figuring out who knows what, how it works. And then I would take the class time that we have. We would meet at the library for an hour, and I would train you on how to use a 3D printer and give you an idea of how that's all done and everything else. Does that sound good? Okay. You probably can't see me. I'm talking to you, but you can't see me because I just noticed my camera's point to the other direction. Sorry about that. For those of you who will watch this video later, and if you have a 3D printer in the area that you're at, I'm trying to remember where my other students are. One is here in North Platte, so you can come and use my 3D printer. The other one is, I can't remember. But if you have a 3D printer in your area, I would like to know if you do, and if you know what type of 3D printer it is, I would like to know that as well. That will help us as we figure out how to go forward with using different 3D printers. They're not all created equal. But I would like to know if you have access to one, where it is at, so that I can try to do the same thing. Find out who's the expert in your area with that 3D printer, make some contacts, see if they can help with this project, and then if they cannot, then I will try to get out there and make that happen as well. But the idea at the end is for all of us to design something, to design this drone copter or drone helicopter, whatever it is, and to test this design, first of all, to design it on the computer, to print it, and to get the prototype actually printed out successfully, which may take a week or more. But then once we have a successful printed prototype, to assemble this helicopter to test it, and then hopefully have time to make any alterations, changes, or even a reprint if necessary. I've set aside 2 weeks for the printing. This is the first time I've done this, so I hope that's enough time. But we will kind of play it by ear. So that is what we're going to be doing at the end here. So I'm going to switch over to my computer really quick and make some changes on the syllabus, which I would recommend you pencil into yours or change on your syllabus if you still have it in a Word format. If you want a Word format syllabus and don't have one still, you can send me an email and I'll send you one. Let's see here, outputs, PC. So here we are looking at my computer, hopefully. Can you see my computer now? No, you can? Okay. So as we get here to SketchUp, the SketchUp portion, we'll be doing training exercises for about a week, and then project for about a week, Thanksgiving holiday. I'm going to write in here possible visits. Actually, I'm not going to put it there. I'm going to put it here because it would be on this date. Possible visits to areas with printers, 3D printers. So that's when we would do that, probably that Monday right before Thanksgiving. And then on the Monday after Thanksgiving, we're going to start off with a project description, which instead of finding a need and trying to clarify a need and everything else, what we're going to actually be doing with the 3D printing and prototyping is we're going to start toolpath, and we'll start the toolpath programming. Up here, we will start our logbooks, and then we'll go down here to 3D printing prototyping, and we will hopefully it'll only take us a day to finish the toolpath, and we can start printing before too long. Here we'll move this up to this one here. Okay. Let's get rid of that for now. Let's put test prototypes up here, probably. Probably want to be testing prototypes no later than Wednesday. Maybe put it on Monday the 5th. Start printing, testing prototypes, reprints necessary. Final test. Okay, so then what we do is what we do for our final in this class is we will do a presentation on your final project, and you will turn in your logbooks for the project. But this week of final exam, we have a whole week that we set aside for final exams where we don't meet for class. So you will actually have some extra time that last week where we would have that presentation to finish up any final testing or anything else that needs to be done for that project. We will not meet during that week, but we will have time to work like you would normally have. And I assume that you don't get out until after we get out. We usually get out a week or two before most high schools. So that should be the case as well. So I will contact the people at your library, see if there's an expert out there, or if they plan on having an expert available before we get there. If they don't, then I will come out and be the expert for a day and teach you to be the apprentice expert, and then you will be able to get on with your printing. And then at that point, you can just kind of, try things and then send me emails if you have problems and pictures from your phone or whatever as you're trying to print. And trying to print is the best way to say it, because you spend a lot of time trying to print and then usually just a short one-time thing printing. You usually run into a lot of issues while you're trying to use a 3D printer. Okay, so the only thing that we have left to discuss here and to make some decisions about is the projects that we're going to do now between here and November. I'm almost tempted to cut this down to 2 more projects and extend this one in November, make it a little bit longer. I'm a little worried about the time. We have 4 weeks. Seems like it's long enough, but I'm just not sure. I'm going to extend it. So what I'm going to do is I'm going to take this hydraulic arm project, I'm going to move it up in time here a little bit. And I'm going to add some time here. I'm going to move this one up to here, maybe. And move these up. I'm going to add some more here. Let's see, I don't know if I need to move them that far up. Let's move this up to, let's see. Let's start first full week of November with our SketchUp. So that moves it up 1 week, is that right? Is all? Maybe I'll move it up 2 weeks. I think I'll move it up 2 weeks. And add some things here. So I'm going to add 2 weeks to that, and it gives us 2 months plus 2 weeks to get it all done. And then we're just left with these 2 projects that we're going to do in October. These are both, both of these projects are kind of mechanical, although one of them is purely mechanical, the other one is mechanical and hydraulic. The hydraulic arm project is a little more involved, so it's a good idea to have a little more time. We'll put a little more time on there. The real question that I'm not sure about is the trebuchet project, because it is also mechanical. I'm kind of thinking of replacing it. We have materials in your kit to do a radio project. And I think that I will change this project to a radio project. I'm going to move this stuff down here. Oops. What did I just do? There we go. Because I want to make sure that we are following the design process while we're doing our projects. So we will do that. I'll just put these down here to remind me. But the radio project is actually a little different, because the radio project is less about following the design process and more about following instructions, which is something that you have to learn to do as an engineer as well. It's an important skill. I'm not going to expect you to understand a lot about how to build a radio. That could be an entire class in and of itself. It is good, nice. There we go. This project is not terribly challenging because it is just following instructions. But there is a fair amount of making adjustments. There's a fair amount of trying different things to make sure it works. And there are actually two parts to the project as well. There's a receiver and there's a transmitter. And I believe that I sent you the kit for both. So what we'll do is we'll start today with the radio receiver project and finish out this week trying to complete a radio receiver. And then we'll complete this project by trying to build a radio transmitter so that eventually you will be able to have one radio on one side of the room or in one part of your school or one part of your house or whatever else that is transmitting something like music from your iPod or whatever, and another one where you can receive that transmission and listen to it. And hopefully you can get both of them to work. The instructions for this project are on a website. I'm trying to remember. Let me see, I think I've got it in my folder here. Project activities. I can't find it there. Let's see. Where else might it be? Well, let's just go look on the internet and see if I can find it. I think I should be able to find it pretty easily here. Science Buddies? Is it Science Buddies? I don't think it was. No, it wasn't Science Buddies. Although that's a similar kit. Mine came from a weirder website. There's a website out there called, what is it? I don't know, it's like Geeks or Nerds, something. What's that? Was it Teacher? No, Teacher Geek is the one. I don't think it was Teacher Geek. It might have been. Let's try it. I don't think it was though. No, it wasn't Teacher Geek. Because that's owned by Ward Science. That's a big company. This one's not a big company. It's more of a small. It's more of a small thing. Let's see if I can remember what else they did in that one. This one also does. I can't remember what it's called. I'll have to find it, I suppose, and send it to you in an email if we run out of time here. Let's try this again. Radio project. Oh, I think I used do it yourself in the search when I originally found it. Wasn't Instructables, wasn't Make It Zine. Vintage Projects, wasn't that? If that was on my other computer, I'd be able to find it without any trouble. But I'm not on that computer. Ah, this is what it was. Sci Toys. Yeah, this is a fun website actually. It's kind of old school. But SciToys is a way that you can make cool things at home with just household materials. They do lots of different little projects here, electric motors and levitation and other things. But one of the things they do is they provide you materials for some of these experiments. And let's take a look at computers and electronics. Here we go, building nope. Yeah, here we go. Computer-controlled radio transmitter. They even have a laser data transmitter, which is kind of like a radio that uses a laser instead of using radio waves. So here it is. We have the instructions for this, and they're actually these parts that are included here. Actually, they're doing Morse code in this one. Is that right? I think that I did send you guys each one of these oscillators. A serial port connector. No, that's not what I wanted. Let's go back to, I'm going to assume that this is going to be electromagnetism. Let's take a look at this one. A motor, 30-second motor, again. Where's the radio? Let's look at the radio. Here we go, a crystal radio, a simple crystal radio. And here they have one for household items, but they also have one for a 3-penny radio and a crystal radio. I think the ones that I've given you is the crystal radio. And the reason it's called a crystal radio is it actually is going to use a diode which has a crystal in it. And I included the diode. It's like a little, it looks like a little, yeah, I don't know what it looks like. It's a little black thing. Well, let me see if they have a picture of it here. I can't see the picture. There's no picture of it. Where's the diode? It's not here. Well, let's take a look at here it is, catalog. There we go. So here they show the germanium diode, which is this guy right here, I believe. So here, actually, it's this guy right here. This germanium diode should be included in your kit, and it's just got a wire coming out each side and a little glass thing in the middle. But I think I also included in your kit a ferrite coil, which is helpful in this as well. And I think I also included a variable capacitor like that. And I think I also included a radio on a chip right here. So you actually, I think I did, I'm not sure. There might also be a battery holder. I think I included all this because it all comes in one package when you buy this kit down here somewhere, wherever it is. The simple crystal radio kit right here. This is what I purchased. So it comes with the earphone. It comes with the capacitor, the germanium diode, and the ferrite core, coil with the core in it. And it also comes with some little clippies. Did you get something like that in your kit? All in a Ziploc bag. You don't have to go look right now. And then the other kit that I purchased, that I sent out, I think, is this one here, wherever it is. Let's see if I can find it. It doesn't look like it's here. But I think that I also sent a kit that is designed to receive this signal at the other, to transmit the signal at the other end. So that's the one that I just talked about is the receiver. Let's see if I can find the one that is transmitter. They don't have that kit anymore apparently here. But anyway, you should have two kits that have electronics in them. And those two kits that have electronics in them will help you to do the projects that we're talking about. The two projects are the simple crystal radio. So if you click on the simple crystal radio, they'll explain they'll give you some details on how to put this together. And they have this thing where they're building this coil, but you don't actually have to build a coil. You actually have a coil that has ferrite in it, and you can use that coil. And then they have their diode in here. You can see that diode there right now. I didn't see it before. And then they connect it to a telephone cord where you can actually connect yours to an earphone, the earphone that I give you, that I send to you. And then you can use that to listen to AM radio actually. Now the other project, which is the transmitter project, is this very simple AM voice transmitter, I believe, which uses these devices here. And I think that you have those parts. Now if you don't have those parts, I will try to send them to you. Hopefully I sent those to you. I'll have to check my kits that I sent out to see that all those parts are in those kits. If they're not in those kits, we'll just do the radio receiver. But if they are out there, we'll try to make the transmitter as well. I've had a fair amount of success with my students building the receiver, and I don't know that I've had anybody succeed at building the transmitter yet, but I can't remember. But you should have at least most of the parts to do this, and those are the next two projects we will do. So make those changes in your syllabus, radio receiver project, and the place that you want to go to is SciToys.com, or I don't know what it is about that. Maybe. Let's take a look. SciToys.com. And you want to do the simple crystal radio project. Just search for that on their website and follow those instructions. I would like you to keep a journal of your, just like we always do, keep a journal of what you're doing with pictures. When you start building this and you might use different materials, you might use some other configuration that ends up working better than theirs, and that's fine. But you need to keep track of that and take pictures and write things down that you do, write down your successes, your failures. And then, write down your conclusions when you're done. Kind of start it off with a statement of the problem and then go through the process of following those instructions and keep track of things. Then the radio transmitter project will also be at SciToys.com. I'll write that down. SciToys.com. And that one is going to be that project is the simple AM transmitter. Let's see, what did they call it on the previous page? Yeah, simple AM transmitter. And I will check the parts that I sent out to you to make sure that I sent the right ones, so that if we have to change the transmitter project or if we have to send you more parts, I can do that. All right, so then once we're done with those two, we will move on to the hydraulic arm project, which will take almost 2 weeks. Well, looks like 2, 3, 4, 5, 6. Will take actually 2 weeks. And we will do a good job of that, hopefully. move on to our final project, which will take the final 2 months and change. Any questions about what we're doing for the rest of this term now? All we will be doing is projects and communication about those projects. Now, for the hydraulic arm project, we will do a little bit different kind of communication. We will be doing more detailed logbook, a more detailed kind of journal, and we will probably also do a presentation at the end of that one. So be aware that we will be doing a little bit more than just the project work. And if there are no more questions, I will be logging off and signing off, and we will be done for today. So have a good day. See you later.